Alright, if I have a vertical number line and a horizontal number line that intersect and form a 90-degree angle, or that's two number lines that are perpendicular, then that will divide my plane into four different regions. Now I'm using a lot of terminology, but actually what I have here, think about this like the x-axis and the y-axis. That's my Cartesian coordinate plane. That's where I could graph something. Okay? So what is that actually, there's a lot of information that goes into this Cartesian coordinate plane that we're used to graphing functions on. Maybe from college algebra or something like that. We know that the middle right here, right in the middle, that's called the origin. Right? And at the origin, you can think about that as the ordered pair 0, 0. Again, this is stuff from college algebra. I'm just kind of reviewing. But you may or may not have ever heard or ever thought of you're dividing the plane into four different regions, okay, by intersecting the x-axis and y-axis perpendicularly. In trig, we call those regions, we call them quadrants. And I guess it's the same in algebra, but we're going to use these a lot in here. Now the first region up here, the top right hand corner, that is what we call the first quadrant. Alright, and the way that we can write quadrant 1 in shorthand is a Q and then a Roman numeral 1. That means quadrant 1. Now if we go in a counterclockwise fashion to the top left-hand corner, we call that quadrant 2, and that's a Q and a Roman numeral 2. And you may also see just the Roman numeral written sometimes. That means it's that quadrant. Alright, if we keep going in a counterclockwise direction, this down here is quadrant 3, the bottom left-hand corner. And the bottom right-hand corner is quadrant 4. Alright, so those four quadrants will be used a lot in here. And they're going to, we're really going to be looking at where x is positive or x is negative, y is positive, y is negative, as we define trig functions. Okay? Well, if I draw an angle measure on the Cartesian coordinate plane, whose initial side starts on the positive x-axis, like this. Let's say that this is the initial side right here of my angle measure that I'm going to draw. And the initial side is on the positive x-axis, because that's the x-axis. No matter where I draw my terminal side, I'm just going to draw one here, so right here. If I draw the initial side on the positive x-axis, that angle measure is said to be in standard form. So if you are working a problem and it says draw the angle measure in standard form, then that means that our initial side, the first side of our angle measure that we draw, needs to be on the positive x-axis. Now, I'm going to draw an angle measure here. Wherever your terminal side is, so you see my terminal side is where I stop my arrow. Wherever that's located, we can say that the angle measure lies in the quadrant where the terminal side is located. So if I called this angle measure here a variable, I'm going to call it theta, the Greek letter theta. It's like a 0 with a horizontal slash through it. Then I can say theta lies in quadrant 2.